Introduction to engines. Gas and diesels are internal combustion engines, also called ICE. Largest components of the block. Cylinder head sits on top, and they're iron, ductile iron, aluminum, magnesium, and even plastics. Here's a typical casting for a V8, pretty straightforward. Here's a cylinder head for either a one piece of a V8 or a straight 4. Typical classifications are V-types, which will come in V4, V6, and V8. Inlines, which will come in anywhere from 3, 4. Some Mercedes had 5 inline and straight 6, typical. And opposed engines like old air-cooled Volkswagens and Subarus. Overhead valves. Before we had overhead valves, many years ago in the last century, we had flathead engines that had valves in the block. So overhead means that the valves are over the engine block. Here's an example of a overhead camshaft, double overhead cam, and single overhead cam. They have a hydraulic lifter, and our engines today have zero lash adjusters, so there's no lash adjustment. Intake stroke, piston goes down and loads the cylinder with air and fuel. If it's a naturally aspirated and a multi-port fuel injected, it'll be the fuel's already in the air side. With direct injected, the fuel's injected the same as a diesel as it approaches top dead center. Compression stroke moves up with both valves closed to compress the mixture. Power stroke, with the valves closed, the mixture is ignited. In this case, it's spark ignition. Pushes the piston down. Exhaust stroke, the piston moves up and pushes the spent gases out the open exhaust valve. Firing order, it's important to know the firing order for the engine that you're working on. We have a representation here of a straight 4-cylinder, which has a firing order of 1, 3, 4, 2. With cylinders number 1 and 4, both at top dead center, are companions, and cylinder 2 and 3, both being at bottom dead center, would be companion cylinders in this particular configuration. Here's an example of firing orders across the board. From straight 6 to V8s and V6s, we have the firing orders laid out. These are typical for most engines built today. Standard rotation. From the front view of the engine is rotating clockwise from the front and counterclockwise from the rear. There are many factors that affect combustion. Incomplete combustion causes the engine to run poorly. It starts at the spark plug gap. It should move steadily across the air-fuel mixture and the expanding gases forcing the piston down. Here's a cutaway example of an engine. This is a V configuration. Straight 4 in line. And here we have a horizontally opposed engine, typically what's in a Subaru. Engine measurement and performance, we have bore and stroke, engine displacement, compression ratio, engine efficiency, and torque and power. Any change to these specifications will dramatically increase or decrease the efficiency and the performance of the engine. Bore and stroke. Here we're showing a representation of the cylinder at bottom dead center and top dead center. The displacement of the bore and the stroke. It's the formula here that's used to calculate how much displacement you have or swept volume. Compression ratio. How many times is the area reduced? In this case, we're going from 8 cubic inches to 1 cubic inch. That's compressing the air-fuel mixture in your typical 4-stroke gasoline engine, and that ratio is what creates the potential for energy. The higher the compression ratio, the hotter the air-fuel mixture gets, and the more power it's going to create. forcing the piston down. Engine thermal efficiency. How much of the fuel is converted into work and how much of the fuel is converted into heat. Those percentages are what's utilized to come up with a reasonable calculation for thermal efficiency. Mechanical efficiency, it takes a certain amount of power to rotate the engine's rotating assembly, to rotate the crank, the pistons, and all the other accessories that are on the engine. Has a certain amount of power required. So if an engine produces 150 horsepower at the flywheel, it's going to have probably 175 to 190 horsepower internally to net the 150 brake horsepower at the flywheel. Here they use an example so you can see how the parasitic load of the rotating assembly and all the components takes power to turn them. Torque versus horsepower. Torque is based on work and horsepower is based on time. That's what is known about the two measurements, and torque occurs before horsepower. Hybrid vehicles have a combination of an engine and an electric motor, and will use both the Atkinson and Miller cycle. Diesel engines are similar to gasoline, except it has a much higher compression ratio to ignite the fuel, and it's larger and heavier compared to a gas engine, produces more torque, and generally runs at lower RPMs. Other types of power plants for hybrid vehicles have at least two propulsions and a small internal combustion engine and an electric motor running off battery. Okay, your basic hybrid does not require to be plugged in, but there are plug-in hybrid engine models that are out there that do require that do utilize smaller batteries because they can charge independent of the gasoline engine. Battery electric vehicles run solely on battery. There's no engine to make any power, so it's got to be efficient. They typically start at 50 to 75,000 watt batteries with ranges going from 150, 200 miles per charge up to 500 miles per charge for the 100 and 150,000 watt batteries. That's what's available today across the board. The typical vehicle will have a 75,000 watt battery and a 250 mile range like a Tesla Model 3. Other power plants, hydrogen fuel cells are rapidly being developed for heavy trucks and other off-highway applications. We have a variety of fuel cells and types of fuel. We have hydrogen that's hydrolyzed from the electrolysis of water, and we also have recaptured hydrogen that is regenerative. Engine identification is here we're showing it on the block and on the vehicle itself. 17-character VIN number and information on the class of EPA tier that the vehicle conforms to. Engine diagnostics, compression test, cylinder leakage test, power balance test, and vacuum tests. Those are all utilized to determine the condition of the engine and its ability to make power. We're going to be doing those 4 tests in shop. Compression test, we have a basic cranking compression test, a dry and wet compression test. If you put a little oil in a cylinder and you run the compression test and the compression improves, chances are it's momentarily sealing the rings to build some additional cylinder pressure. Running compression test will identify valve train problems like worn cams and broken valve springs and other overhead concerns with the valve train. This is a graphing version of a relative compression test. This is a graphing version of a cranking compression test, running compression test graphic version on a scope. And this is the scope version of a running compression test showing that we have a concern in the valve train at that location. Knowledge check, 4-cylinder engine that has the following compression reading. What would cause those two cylinders number 3 and cylinder number 4 to most likely have much lower compression. Let's figure that out. Cylinder leakage test, you're pressurizing the cylinder to approximately 100 psi, and you have a small amount of allowable leak down in a period of a minute. And you'll have, if you have a failure, you'll have air leaking out of an exhaust pipe if it's an exhaust valve, leaking out the intake side if it's an intake valve, and it will also cause bubbles in the coolant if it's a cylinder head. So there's a few tests that can determine quite well, putting the air into the cylinder and identifying where the leakage occurs. Power balance testing is done electronically with a service tool. We've been doing those power balance tests in other applications, but using cylinder cutout and balancing. Lab scope, monitoring crankshaft sensor and cam sensor, comparing signals to a known pattern, and aligning timing marks and verifying ignition timing that it's correct. Tech A says the cylinder should be dropped the same RPM if it's balance testing, and Tech B says a cylinder that does not drop is a good cylinder. What do you think? Who do you think is correct? Engine oil pressure testing. Essentially, you can unscrew the oil pressure sensor, and it's typically a 1/8 or a 1/4 inch NPT adapter that goes to your oil pressure gauge, and you can determine if the engine does in fact have oil pressure, and is it failing from the oil pressure sensor out to the control module and over to the gauge, and how we can utilize fuel fluid leaks and exhaust smoke. Gray and black is excessive fuel, blue is burning oil, usually coming from the valve train or through the rings, and white smoke is coolant or transmission fluid and combustion, either coming from an oil cooler or coming through the cylinder head or cylinder head gasket. Abnormal combustion noises, a detonation or a ping is bad timing, and having a problem with overheating or a dramatically lean mixture. Pre-ignition occurs with the low octane fuel, and having carbon deposits, spark plug concerns, and firing across the cylinder and having an echo, which is going to give you that knock. Having detonation and knock occurring, and if it's allowed to occur and the engine is run in that condition, it can very easily destroy the pistons. Excessive carbon buildup causes thermal problems. The heat isn't able to transfer into the coolant, and there are methods of using additives like seafoam and walnut shells to break up deposits if you're doing an overhaul. Ring noise is high-pitched rattling. Piston slap is when the engine is cold and it hasn't gone to fully round and made it to temperature yet. That takes a moment. Pin knock is a hard metallic knock, and ridge noise is a rapping louder on deacceleration. That's the piston and the piston ring hitting the carbon ridge. That's at top dead center for the compression ring. Rod bearing noise, rattling at an idle. Main bearing noise is a dull, steady knock. Tappet is a regular clicking sound that's timed to the RPM of the engine. And pinging detonation is a rattling noise during acceleration. Okay, you could watch this video. And that's it for our basic engine.
I